Hi, I'm Apoorva Agarwal and we present SeRVo-HOI, a skew-robust human-object interaction detection method for video inputs. The task of HOI detection in a static setting, that is when the input is image, is to detect human object and the interaction between them. Here, person hold the toy is the pair of interaction. In the dynamic setting where the input is video, we predict both spatial as well as the temporal relation between the human and the object. Example of spatial relation is hold, above, watch, and of temporal relation is run, pull, open. We train and evaluate the proposed pipeline for the task of video HOI detection on VidHOI dataset. It has in the wild videos there are 50 predicate labels and 78 object labels. Our dataset consists of 7K video corresponding to 7.3 million frames. The dataset is challenging because of occluded human and high dataset skew and multi-label nature of the dataset. Overall pipeline of the proposed SeRVo-HOI architecture, given an input video segment with frames and corresponding bounding boxes coordinates of the human and the objects in every frame, we first extract the visual features using the ResNext 101 and the ROI trajectories of human and the object. Next, the per ROI features are extracted using ROI align and aggregated together along with the pose and the spatial features before being finally put to the 3D convolution classifier that classifies the interaction. The performance of SeRVo-HOI in Oracle mode, where the network is trained and evaluated with the ground truth bounding box trajectories and human object categories, and in detection mode, where the trajectories and class scores of the human and objects are retrieved from an off-the-shelf object detector. In both the cases, the SeRVo-HOI method outstands the existing methods. The predicates in SeRVo-HOI dataset have high dataset skew. The frequency of the action labels range from 5 million to 8, where top two most frequent labels, that is next to and in front of, constitutes to 63.86 of the total labels, and the least frequent 10 labels constitute to 0.04% of the total labels. Loss function. To handle the dataset skew, different loss functions are experimented. First is the generic BCE loss, which is used by the STHOI baseline method, uh, and with and there is weighted BCE loss and positive weighted BCE loss to reduce the effect of the frequent labels and to enhance the performance of the least frequent labels, and the focal loss, which dampens the loss for the well predicted instances and thereby increasing the contribution of the poorly predicted instances. Conclusion: we propose a novel pipeline that identifies human object interaction in videos. We achieve state of the art results by carefully crafting a network that accounts for the spatial and the postural cues of the human body. In addition to this, we address the problem of dataset skew and demonstrate improved performance on rarer classes. In future, we intend to work on the long-tail distribution problem in the context of HOI, and as well as propose a pipeline for holistic HOI detection and recognition.